Hello everyone, welcome back. Chris Boffman here with the manufacturing program for Central Oregon Community College. We're going to be going through chapter 2 of the Welding Principles and Practices book. Again, same thing as before on chapter 1. Make sure to take really good notes, highlight items. You know, we're finding that the majority of the PowerPoint goes exactly the way the book is laid out as well, which same manufacturer, both. We purchased it for that reason, to help aid you through reading the PowerPoints. You can always access the PowerPoint on Blackboard after watching the lecture or so forth. And start out with page 1, going through it in that manner, in that fashion. Okay? So let's start into it. Chapter 2, Industrial Welding. The first couple of lectures here that we talk about are a lot of just kind of information to give you a big overview. As we can get going through chapters further through the program, we start getting into a lot more detailed information and so forth. Okay? So there are two major functions in industry: means of fabrication or maintenance and repair. You're either building something or you're fixing something for the most part. Now, a lot of people say, what about artwork? Well, you're still fabricating artwork. You know, for the most part, everything falls in here. There might be some strange situation to where it doesn't. However, these are the two biggest reasons, and that's why they're the two major functions within industry. Difficult to find single industry that does not utilize welding. Again, so we might talk about a composites manufacturer, right? However, most composite manufacturers, most of their equipment that creates composites or computers, so forth, may not be made of metal, but plastics. The equipment that manufactures that product has some sort of a welding, usually in a steel or a stainless steel type material or metal material that it is made of. Okay. Move on. Industries where welding is an advantage: aircraft, automotive, bridge. There is a lot of industries that we use that use welding. You can get more advanced. Some of them are very simple welds to very critical welds. Okay? As you can see, there is a ton of industry out there. All right. So, this is page 1, or chapter 2, page 13. Starts out, it may be said that welding has two major functions. We talked about that, either fabrication or maintenance and repair. Might be important to know. Those are bulleted items. Page 14, left-hand column, fabrication. Welding fabrication has grown rapidly because of its speed and economy. Welding plays an important part in manufacturing processes for the following reasons. Again, if I read it, I highly recommend that you highlight it at some point. Okay? More than likely, I think it's important, or you may see it again on a test further on throughout the program. Okay? Greater design flexibility and lower design costs. I'm just going to hit the bulleted points, bulleted items. You can read through them in the book, what they are, and I want you to. The elimination of patterns, lower cost of material, fewer worker hours of production, absorption of fixed charges, minimized inventory, obsolescent charges. I don't know if I said that word right or not. Let's go back to lower cost of material. This is kind of an important one, just to give you an idea. People say, well, steel's so expensive versus something plastic. It is. However, depending on what it is used for, okay? Rolled steel is a stronger, stiffer, more uniform material than castings. Therefore, fewer pounds are required to do an equivalent job. Also, since rolled steel costs 1/4 to 1/2 as much as casting, the cost of material is cut by as much as 3/4 by using welded steel fabrication. By replacing riveting, welding fabrication saves more than 35%. Wow, that's crazy. Welded steel construction eliminates connecting members such as gusset plates, simplifies drafting, cuts material cost and weight from 15 to 25%. Bolded item in that especially, welding permits the use of simple jigs and fixtures for speeding layouts and fabrications. Okay. Also, just on a side note, you know, a lot of times the ironworking and steel industry gets somewhat of a bad rap as far as the green energy sector. Just a quick information on that. Steel is the most widely recycled material in the world. So much more than plastics and steel. So a quick example without being definite figures, I believe it was like 50 billion tons of steel recycled last year versus only 1.2 million tons of plastic. It's 70%, I believe is the statistic, 70% of steel in America today comes from recycled steel. It's not being mined or ored, it's recycled material. We are adding a lot of alloys and improving the properties of steel every day. And they're coming up with different technologies and finding out things that are a benefit to the steel making process and so forth. Okay? Kind of important to know, because I never would have thought that much steel was from recycled steel in the country today. Okay. Let's moving on. Let's go to maintenance and repair. Chapter 2, right-hand column. I want you to read through that. Hundreds of companies save thousands of dollars by using welding for maintenance and repair, the addition of new metal, and repair and replacement of broken parts. Again, hard-facing worn parts produces part more serviceable than original at saving. See if I can spin this over here. Give you a quick overview. So when we start talking about hard-facing material, it's not just on heavy equipment, but say even road equipment, road construction equipment. Okay? So as strong as steel is, when it goes up and down the road on dirt, pavement, it wears out very, very fast. So you might have a piece of material that gets wore out like this, okay? And that replacement part might be $4,000 or $5,000. However, as long as you were to maintain it, you could weld this up back in down to its original shape, and then you could come back in behind that and put a harder hard-facing material on it. Okay, a lot stronger hard-facing material that has some abrasion resistance, maybe some impact resistance, so forth. All terminology we're going to get more and more familiar with going through the program as well. Okay, but you build this up. You're going to start this first thing, building a pad. You build that up, goes up and down the road. Say this lasts 4 months versus before just a plain piece would have only lasted maybe 2 months. That's, you know, half the time. Twice again as far as service equipment, correct? So less equipment, downtime, less money. You just took a $5,000 part. If you'd had to replace that twice, it would have been $10,000. By welding it up, you still only have the original part in it, okay? Just a quick example of hard facing and why one of your first welds in the welding shop is going to be building a pad. Basically the same thing as hard facing, getting equipment where you want it to be. Okay, all right. That also ties into repair and replacement of broken parts. You know, that liquid metal doesn't have to be an exact line. It doesn't have to be perfect. You can put it back up there, repair it. Usually you want to try to figure out why it broke, or what shortened its service life as well. Okay. Special needs. Special needs is especially important as far as modern technology. If you notice, we're getting, our homes are getting more open designs, right? Foyers are being 2 to 3 times larger than they used to be. Well, they don't make, you know, that big of trees, or we don't want to cut them down, so forth. Steel is an easy way to go. We get high strength, less deflection, and we can create and engineer different methods to be able to get greater spans with still added strength to that material as well. So modern technology within homes is a very important part of this, along with buildings, skyscrapers, bridges, so forth. Okay. Come back here real quick. We're on page 14, right-hand column under maintenance and repair. Let's go down to industries. Okay. Aircraft. Wood, fabric, and wire were the principal materials to be found in the first airplanes. With the change to metal construction, the industry became one of the foremost users of the welding process in all its forms. Aircraft welding was first tried in 1911 and used in warcraft production by the Germans in World War I. Some few years after the war, the tubular steel fuselage was developed and production lines were set up. Next page. Today, welding is universally accepted by the aircraft, missile, and rocket industries. The development of supersonic aircraft and missiles involving increased stresses, high temperatures, and high speeds have presented fabrication problems that only welding can meet. Okay, let's hit this real quick and then we'll continue in the book. So it was first tried in 1911 in warcraft production by the Germans in World War I. Here we just talked about a minute ago with modern day homes, how we're getting larger homes, greater open areas, so forth. Welding meets fabrication problems of increased stresses, higher temperatures, and high speeds. Believe it or not, steel can be very flexible as well. So it can have a lot of malleability and ductility within it to be able to flex and give somewhat. Think of a bridge. A bridge is not very straight, or it's not very super stiff. It has to be willing to bend and flex as cars and weight goes over it and we get vibrations and so forth, okay? Especially on West Coast here where earthquakes and seismic activity can play into a lot of our building structures. It's important to have the correct engineering specs, correct welds, and the correct material in there, because different materials have different qualities with them. Some are more brittle to where they snap easier, they don't handle as much vibration. It's not what we really want in a high earthquake area, okay? So, concerned with aerospace at this point, let's go back to the book. Page 15, left-hand column, second paragraph down. Welding processes employed in the aerospace industries, it refers to several figures on the page here, include all types of fusion, solid-state welding, resistance welding, brazing, and soldering. Aircraft welders performing manual welding operations are required to have qualification certification. Again, you would not want a beginning welder welding on an aircraft that you're putting people's lives in, okay? You want to make sure that they're qualified, certified welders, keep the proper documentation. There's a lot of oversight and checks and balances that go within the quality assurance thread of welding as well. Okay? All right. Welding is used in the fabrication of the following aircraft units: pulleys, structural fitting, mufflers, exhaust, axle and landing gear parts, a whole list of bolted items. Okay? Again, aircraft welders required to have qualification certification. All right. A lot of stuff. Even as we're going to new composites, there's still a lot of welding that takes place on airplanes. Okay. Kind of cool. Using the construction of the Nighthawk stealth fighter. Interesting stuff. All right. Okay, we're flipping now to page 16. We're underneath the automotive section, second paragraph down. Welding is the method of fabrication for the whole automobile. It's the joining process used to build the body frame, structural brackets, much of the running gear, parts of the engine. Welding also is a necessary process in the service and repair of automotive equipment. Yeah, there's some nuts and bolts on it, and they do go together. However, a big portion of the panels are welded together in different fashions using different processes as well. Okay? I've skipped over the first section. Let me go back to it real quick. Welding processes for the manufacture of passenger cars, first introduced during World War II. Since that time, the automobile industry has employed welding on a large scale. All right, page 16, right-hand column, top, second paragraph down, it starts out, welding is used extensively in military. Okay? Here's an example of robotic welders assemble a vehicle chassis, firefighting equipment. All right, back to the paragraph we just found. Welding is used extensively in military automotive construction and in the construction of all types of vehicles. Many people are not familiar with the many types of military automotive equipment, since much of this equipment is of a secret nature. That just sounds cool. That just makes us even cooler as welders already. Welding method of fabrication for the whole automobile, blah, blah, blah. And it's a highly effective way of joining two high-strength pieces of material. Skip down to the bottom of that paragraph, or that bottom of that column. The paragraph starts out, many dollars have been saved by passenger car owners and truck operators. The application of welding is a method of repair. Alert mechanics who are quick to realize the utility of processes have applied it to automotive repairs of all types. Within the PowerPoint description here, it's used for a lot of material, okay? So for example, engine heads, engine blocks, oil pans, cracked and broken frames, so forth. Now, engine blocks a lot of times are made of a cast material. However, you may be able to braze weld them back, torch braze them, okay? You can gas weld steel, you can use bronze. There's different things you can do with different materials to be able to help the fusion and welding processes. All right, let's go into construction machinery. Next paragraph down, the highway to Alaska was built in 9 months. 1,600-mile highway through what had been considered impassable terrain would have been impossible without imagination, daring, and proper equipment. That's pretty impressive. So this is a 797 haul truck. I worked at a coal mine in Wyoming for a while. We worked on 777, 777. You can see this gentleman here standing at the base of this. That's a lot of irons. Just to give you a good example, we would always find cracks in the beds. You know, this bucket itself is probably a 200 cubic yard bucket, 200-ton bucket. Dump material, come back down, big hydraulic rams, lift it up, bring it back down. Well, sometimes they hit a little harder than they should. Well, the metal starts wearing out. We would have to pull these up, secure them, weld blocks to them to where they would not collapse on us. We'd go in and we'd do build up and weld on the pads to keep them to where they would sit down nice and even. We'd save a lot of money, be able to help align things as well. Just for example, cutting the wheel studs out of changing these tires was a tremendous amount of work. There was out here on the dually, for example, there was 96 wheel studs on each side for the bigger ones. On ours there was 42. cutting them off. They're large steel studs, about 1.25 inches a piece. You would cut them off, you'd take a torch, drill a hole through them, so forth. Occasionally you couldn't get the hydraulic press out there or on the equipment to do that, so that's why you would have to oxy-fuel cut them. Be diligent, make sure you didn't get into the hub. Otherwise you would have to pull the whole axle out, send it off to get it repaired, thousands of dollars worth of repair. One of the most common things that would break, safety is very important. When the miners out here walking on this deck, that the railing is their safety net, so that they don't walk off the edge of it. Going up and down dirt roads and rocks and everything else, sees a lot of vibration on the catwalk. So you'd constantly be having to fix or weld those to keep the truck drivers safe. Okay? This is Caterpillar. Caterpillar's for everything from mining to road equipment to, I mean, they make toys now. So, huge global industrial application, can have many aspects within it. Okay? Pretty crazy. 3,400 horsepower diesel engine. There you go. I don't know, it says not the size of a worker. That's pretty close. Smaller version, we'd be a couple feet above this, but that one's probably very close comparison-wise to the 797. 1.2 million pounds. It's a lot of material. All right, moving on. Household equipment, welded fabrication, so forth. Let me back up and read some from the book, okay? Page 17, right-hand column, second paragraph down, it starts out the design of an earth-moving unit fabrication entirely by the welded method. From mill-run steel plates and shapes, reduce the weight of the total earth-moving machine from 15 to 20% over the conventional method of manufacturing. So, and then of course now they're getting more alloys that are a lot lighter. So you take 20% of this, 20% of 1 million is 200,000 pounds. So that's a lot. 1/5 of this is close to, say it's 250, so there's another 50, that's 230,000 pounds off of that. So say that's the original weight at 20%, you could shed that 230,000 pounds off and it would only be 1 million pound piece of equipment. So again, technology and the way we're going, we are saving a tremendous amount of weight, control, at an efficiency as well, okay? Back to the page again, page 17, right-hand column, bottom paragraph. Some idea the tremendous job is being done can be gained from the following comparisons. I want you to read through this chapter. Just a good read, okay? Next page, page 18, left-hand column, bottom of the page, household equipment. The application of welding to household equipment plays an important part in today's economy. Welded fabrication is popular in those industries engaged in the manufacture of tubular metal furniture, kitchen and sink cabinets, sinks, furnaces, ranges, refrigerators, and various kinds of ornamental ironwork. Much of this work is done with resistance welding, gas tungsten arc welding, gas metal arc welding, and brazing processes. Okay? Again, it's not just on big equipment. It's not just there. It's on stuff like this as well. Okay? Next page.